Hi everyone, today we are doing Lab 6, which is aerobic capacity. If you look at slide 1, we're doing maximal oxygen uptake. The concept of VO2 max was addressed last week. It is defined as the maximum amount of oxygen consumed per minute during large muscle mass exercise. Next slide, VO2 max serves as an indicator of aerobic capacity, so your blank is aerobic capacity, and cardiovascular fitness. Greater aerobic capacity equals a greater ability to deliver and utilize oxygen during exercise. It is primarily determined by genetics, so your blank is genetics, but can be increased by up to 30% with training. Next slide. Important to remember that measurement of VO2 max is exercise or mode specific. Example, a treadmill test will often result in a higher VO2 max than a cycle test, and that is due to greater muscle mass, so your blank there is muscle mass being utilized, and greater efficiency on the treadmill than the cycle. Next slide is 2 units of measurement. The first is VO2, or absolute VO2. That's measured in liters per minute. And then relative VO2 is measured in mils per kg per minute. Relative allows for comparisons among people with different body masses. Go to the next slide, indicators of VO2 max. Direct assessment for valid determination of VO2 max. So the first blank there, direct assessment for valid determination of VO2 max. Must see an observable plateau in VO2 with increasing workloads. Secondary criteria are sometimes used but not as valid, so that's the next blank. Secondary criteria sometimes used but are not as valid. RER above 1.15, heart rate at or above the predicted max, which is 220 minus age, and third is volitional fatigue, which is muscle fatigue. The person just has to quit. Moving on to the next slide, it is respiratory exchange ratio, or RER. RER is measurement of gas exchange, so your blank is gas exchange at the mouth, CO2 produced over O2 consumed. Can be used to predict which macronutrient is being used during exercise to produce ATP. So at 0.7, an RER of 0.7 would be you're using 100% fats. An RER of 1.00 would be 100% carbohydrate. Resting RER is usually about 0.8, or 1/3 carbohydrate and 2/3 fat. Next slide is VO2 peak. If the VO2 max indicators do not occur, then a VO2 peak occurred. So your blank there is VO2 peak. A VO2 peak is the VO2 reached by the subject but is not necessarily the max. So your blank there is VO2. If you look at those two slides, there is a VO2 max reached on the left. There's a plateau in VO2 with increasing work rate. But on the right, that would be an indicator of VO2 peak. You don't see a leveling off of VO2 as work rate is increased. Next slide is bicarbonate buffering. That system works to relieve the body of excess hydrogen ion, or H+, that comes from lactic acid dissociation. So if you see the reactions there, lactic acid yields lactate plus H+, and then bicarbonate is HCO3, and that's a negative, plus H+ yields water, H2O, and CO2. The bicarbonate buffering system is very important as extended exercise would be impossible without it. Note that lactic acid is not the culprit responsible for fatigue during exercise. So your body gets that extra hydrogen ion buildup, that's more acidic, that makes your muscles burn. That bicarbonate buffering system generates water and carbon dioxide, and then your body's able to blow off that carbon dioxide so it can regulate your hydrogen ion and keep your pH where it's supposed to be. Next one is relevant equations. VO2 equals VI times FiO2 minus VE times FeO2. And then it tells what each of those variables stand for. VI is volume of inspired air. The VE is volume of expired air. FiO2 is fraction of inspired oxygen. FeO2 is fraction of expired oxygen. And RER is VCO2 over VO2. So you're going to end up watching some videos of a max VO2 test, and then we're going to take you through the calculations in your lab manual.